What's up everyone? In this video we're going to be talking about dilating lines on the coordinate grid. So going back to a general definition of a dilation, it's a scaled image where we're stretching or shrinking a figure. And remember that for a dilation we need a scale factor, which is the lowercase letter k, and we need a center of dilation. Now what you should remember also is that this center of dilation never changes. So similar to when we have a center of rotation, right, how that point is staying constant, the center of dilation is also never changing. Now, in this lesson, we're specifically going to be dealing with some line dilations. And when we dilate a line, what's going to happen is we are going to be creating another line that is parallel to our pre-image. So no matter what, if I drew this original line here, no matter how much I dilate that, I can make it really big like this, or maybe my scale factor is a little smaller, maybe with the center like over here. No matter what my scale factor is, I know for a fact that my images are always going to be parallel to my original line. Now remember, when lines are parallel, we know that their slope is always the same, right? So the slope of lines, when we dilate them, the slope of that line is not going to change at all, no matter how many times we do it. So remember our formula for our scale factor, and then this is dilation notation. So in this lesson, we're going to be dilating these lines and coming up with equations of the images. So remember, what we recommend to do for equations of lines is kind of remember this point slope form, where it's y minus y1 equals m times x minus x1, where m is our slope. So that's the first thing that we need when creating the equation of a line. And the second thing that we need is a point on the line. So in this case, that's going to be our x1 and our y1. So in this example, line AB is drawn and passes through the point A, -2, 6, and B, 4, 0. If CD is the image of AB after a dilation with a scale factor of 1/2 centered at the origin, we want to write an equation to represent the equation of that new line that we get. So these are the steps to do a line dilation. So we know, again, no matter how much I dilate this line by, that it's going to give me a line with a parallel slope, or with a exactly the same slope, right? So let's find the slope of our original line, because that's going to also be the slope of our new line. Because remember, to create the equation, we need the slope of our line and we need a point on that line. So let's first find the slope. So you can do this in two different ways. They give you the coordinates of A and B. So what you can do is use those coordinates to mathematically find the slope. So if we mathematically found the slope, we would have to do x1, y1, x2, y2, and then our slope is going to be equal to y2 minus y1 over our x2 minus our x1. And remember that double negative is going to turn to addition, so 4 plus 2. That's going to give us -1 for our slope, right? Now we could have also just done this by counting stuff on the graph. If you pick any 2 points, like let's say I pick these 2 points, you can see, okay, clearly I'm going down 1 and to the right 1, right? So I know that this is going to be the slope. The slope of line CD is also going to be -1, right? Because we know that CD is going to be parallel to this line AB here. The next thing that we need is a point on our image. So I need to find a point on line CD. We already have the slope, but now I need to somehow use my knowledge of dilations to find a point that I know is going to be on line CD. So what we got to do here is just choose any point on the pre-image. Choose any point on the original line. I usually like to choose the y-intercept because it's like the easiest thing for me to dilate, but you can pick any point on that line. So in this case, I'm going to pick the y-intercept. So what's happening here is we are dilating every single point on this line by a scale factor of 1/2. Now, really what we're doing is we are having the distance from all of the points to the origin. So I choose the y-intercept because you only have to really count the distance in one direction, right? In this case, point P is 1, 2, 3, 4 units away from our origin, and we want to half that distance, right? So if we half that distance and only go up 2 from the origin, I know P prime, this point on here, is going to be on line CD. So P prime on line CD is the coordinate 0, 2. I know for a fact that 0, 2 is ending up on that new line. So not only now do we have the slope, but we also have a point on that line, right? So we know that our m is equal to -1, and the point on line CD is 0, 2. So now all we need to do is substitute that into our point slope form. So y minus our y1 gives us y minus 2 equals our slope, which is -1 times x, minus our x1, which is 0. Now this is a totally acceptable answer, but you guys have to be comfortable with both forms. So also being comfortable with manipulating this equation around a little bit and distributing that -1, we'd get -x plus 0. And that 0, you don't even need to write it. But then you add 2 on both sides to get y equals -x plus 2. So both of these equations you should be able to recognize. And that's it. So again, we just need the slope of our new line, which is always going to be the same slope as our original line because the image is parallel. Always. The image of a line when it's dilated is always parallel. And then we chose 1 point on our pre-image, and we dilated that by our scale factor so that we had a point to plug into the equation. Now, if your center of dilation was different, right? In this case, we were dealing with the origin. If our center of dilation was different, let's say our center of dilation was this point here of 2, -2. If this was now our center, now we have to base our distances from this point. So when we're finding the equation of our line after it's dilated, the slope here is not going to change, right? Because we already talked about whenever I dilate this line AB here, whenever I do that dilation, I'm going to result in a line that is parallel, right? And that means that our slope's not going to change. So step 1 here does not change. But step number 2 talks about finding a point on the image, right? So we're taking a point on line AB, which before we used the y-intercept here of 0, 4, and we dilated it, right? But when your center of dilation changes, the way that you measure the distance also changes. So before, we went up 4 from our origin, so we were just able to go up 8 to double that distance. But now if our center's here, we got to account for that change. So to get from C to the point that we chose, to get from our center of dilation here, we have to go to the left 2, and up 6, right? So if we want to half that distance, instead of going to the left 2 and up 6, we're going to go to the left 1 and up 3. So left 1 and up 1, 2, 3. So then our point would be here. That would be the point P prime if our center was different. So again, step 2 changes when your center of dilation is different because your point's going to end up in a different spot. And then that's what you would plug in step 3. Okay, so just be mindful of knowing what your center of dilation is, and just be mindful of how that affects you actually dilating those points. Here are some main takeaways from the video that you guys just watched. So number 1, to create the equation of a line, you guys know that we need the slope of it, and we need a point on that line. And once we have that, we substitute it into that equation there, and then we can manipulate it if we want to. Now, other thing is a dilated line is always parallel to its pre-image, which means that the slopes must be the same, and this is so that you can get m to substitute into the equation above. And last, you can choose any point to dilate from your pre-image to get a point on your image. Now, this is so that you can get x1 and y1 to substitute into the equation above. Just be mindful of your center and make sure you are dilating that point correctly based on your center.